All right, so now we're going to get some solving for x-intercept problems that have holes and some reducing out. So we're going to follow through our process and just see how the problem works. Starting with step 0, which is to factor to produce and identify our points of discontinuity. So we want to go ahead and use the magic x. It's a trinomial. Negative 70 goes on top, and then the 3 goes on the bottom. And we figure out 10 and negative 7 should produce a product of negative 70 and a sum of 3. So we go ahead and factor the denominator to be x plus 10 and x minus 7. And if we set each of those equal to 0, we will identify that x equals negative 10 is a point of discontinuity along with 7. So my domain is all real numbers, comma, x can't be those two things, negative 10 and 7. Our goal, though, isn't to do that as much as it is to identify our x-intercepts. I'm just saying that it can't be those two because those two are not in the domain. So now we go ahead and factor the numerator, now that we've identified our points of discontinuity, using the magic x to factor. 21 goes on top. If you multiply by the 1, 21 times 1 is 21. Minus 10 on the bottom, and then we go ahead and get a product of 3 and 7. Both of them have to be negative so that we get a negative 10 result and a product of 21 that's positive. So then we factor that trinomial, which gives me x minus 3 and x minus 7. I'm going to go ahead and rewrite my function over here to the right of it so that we can reduce and identify that one of our numerator factors is a whole. Now, what I'm trying to get us to find out is that now that I factored the numerator, I can reduce this x minus 7 because anything divided by itself is 1. So we put a big 1 there. The reduced function f of x is equivalent to x minus 3 over x plus 10 everywhere except when x is the positive 7 there. So my goal is to, now that I've reduced, I'm not actually going to talk much about the vertical, although I'll say it, the 7 reduced out, so it's a whole, and the negative 10 is a vertical asymptote. But the point is not about that here. Our goal is to get to step 4, which is to set the remaining numerator equal to 0, which is just this x minus 3 part. So we set that equal to 0, and we solve for what would cause that to be 0. So x minus 3 equal to 0 will produce x equals 3 as a 0 in x-intercept. My x-intercept is 3, 0. Because when I plug in 3 in the numerator, it will be 0. If I did that at the beginning, it would be 0. Up here, 7 would have caused the top to be 0 as well, but 7 is not part of my domain, so I do not include 7 as an x-intercept. My answer for x-intercept for this one is 3, 0. So this is the first time where we had to sort, where had I just solved from the beginning, I would have got 2 answers. One of them would have been wrong. So it's better to reduce and then get to step 4 after reducing to identify x-intercepts from the numerator after reducing.